Okay, in this section, we're going to learn about the margin of error. The margin of error is associated with an estimate of population mean that can be interpreted as the maximum likely difference between the estimate and the actual value of the population mean for a given sample size. To simplify that, it just means how far off you are, mostly how far off you are likely to be. What's again really important here, and we talked about it a little bit earlier, as sample size increases, your sample is better. So as sample size increases, your margin of error should decrease. Okay, so if we go over here, we have the formula for the margin of error. And this is your margin of error with a 95% confidence interval. It says down here, this is for a confidence level of 2 or 95% confidence. In Math 3, the only thing we're asked to do is a 95% confidence interval. If you were to take a statistics class, you would learn more about that. But for this class, it's always going to be this formula that we are going to use for our margin of error. In this formula right here, your S stands for your standard deviation. And I will show you in a minute how to find that using Desmos. And N stands for your sample size. And the sample size is the number of people in your sample, how many people you looked at there, or individuals, or whatever you're looking at. So let's do a problem. Actually, no, here's our next one. The margin of error can be used to find the confidence interval. And this is a range of values, so to find that there is a specified probability that the value of a parameter lies within it. The 95% confidence interval is given by this equation here. Now this looks very complicated, but all you're really going to do is add and subtract the margin of error to the mean of the data. So X with a bar over it in this equation right here is your mean, or your average. So what you do is you take your mean and you subtract the MOE, which is margin of error, and that's going to give you your lower number for your confidence interval. And then you take your mean or your average and you add the margin of error, and that will give you your upper values for your confidence interval. And in this case, X, which is going to be your parameter, lies in between, and that parameter is just whatever you're trying to measure there. So let's look at how to do this in Desmos. So Desmos will do most everything that we need it to do, everything we need it to do here for us. So we'll be using it for the majority of what we're looking at. So if I want to be able to find a margin of error, or different things in Desmos, I first need to know how to enter that data into Desmos, and then how to find things like my mean and my standard deviation. So for example, if you have a list that you're wanting to use, you can label it any capital letter. Like I like to use L for list, but you can use whatever you want, and you're going to use square brackets, and then you just enter the numbers with commas in between them. 1, 2, 3, 4, 5 is the example I've used over here. It will tell you over here how many numbers are in your list. This is helpful if you have a really big list. Clearly here, this one's pretty easy to tell that I've got 5 numbers. If you want the average or the mean of the data, you could do 1 plus 2 plus 3 plus 4 plus 5. Add them all together, you will get 15, and then divide by the number that you have, which is 5, and then that would give you 3. But Desmos has this programmed into it, so instead, another option is just to do mean L. So you type the word mean and put L, and it will be 3 right there. These are also available from the functions menu. So if you go to functions down here for statistics, you're going to have a lot of options. You can see right there mean is one of them. To find standard deviation, you also could go to this menu, or you could just type it in. You've got two options here. You've got STDEV and STDEVP. And in this case, since we're looking at a sample and not the entire population, we would want to use STDEV. So if you have it memorized, you can just type in STDEV, but sometimes kids have a hard time remembering it, so you can go to this menu over here and just choose that, and it's going to give you a number here for your standard deviation. So the mean there is, let me go back to full screen here, the mean is the average of the data set. It displays like the middle of that data. And then the standard deviation, calculating it is a little complicated. We're not going to go into that. But what you really need to know is it's a measure of spread for the data set. So it tells you how spread out the data is. If that number is bigger, it tells you the data is more spread out. If that number is smaller, it tells you the data is less spread out. So here's an example where we're going to be finding the margin of error, and this is going to sort of walk us through this. I'm going to split screen again so that we can look at Desmos here. And so this gives us the body temperatures of one random sample of healthy adults in this population. So I'm going to clear out what I've got here. The first thing they ask us to do is find the mean temperature for this sample. And to do that, we need to type these values in. So I'm going to call it L equals bracket. You can use any letter that you would like. 97.73. Put a comma in between each number. 98.76, 98.27, 99.95, 98.47, 98.49, 98.97, 98.68, 99.27, 99.25. So we've got 10 different elements entered here. I hope I have typed them all in correctly. That's one of the biggest challenges here, is making sure you type everything in correctly. We'll double check back through. 98.7, 98.9, 98.97, 98.68, 99.27, and 99.25 looks right. For the mean, I'm just going to type mean and L. And so I'm getting 98.78 or 784. So 98.784 is my mean. For standard deviation, I'm just going to type in STDEV L. And I'm getting 0.616. Please keep at least 3 decimal places for these. The sample size for this sample is 10. It's just the number of people that you took their temperatures here. We're looking at body temperatures of 10 different healthy adults. D asks for the margin of error for this sample. So that margin of error formula was 2 times standard deviation divided by the square root of the sample size. So for this, it's going to be 2 times that standard deviation, so 0.616, divided by the square root of 10. And so we are going to type that into Canvas over here, Desmos over here, 2 times 0.616. Actually, it will be better actually if we copy that number and paste it, and then divide that by square root of 10. And so I'm getting 0.3898. So that is my margin of error. That's how far we can be off here. So if I want the confidence interval for this sample, I'm going to take my mean value, which was 98.784, and I'm going to add or subtract my margin of error. So first, I'm going to take that mean right here. I'm going to just copy it. That's my mean right there, and I'm going to subtract that margin of error, which is the 0.3898. And I'm getting 98.9394, so 98.394, and then I am going to add. So I'll basically just go change this to a plus sign, right? Take our mean and add that margin of error, and I'll get 99.174. Okay, and what this tells us is that 95% of people should have temperatures between 98.394 and 99.174. That should be the range that we are seeing here. If you're below that or above that, then something is not right. So if you are like Henry is right now and it's 101.2, you might need to go to the doctor there. So if we took a sample of 10 healthy adults and found the average to be 98.95, would that be unusual? So we generally know that they tell us that 98.6 is your average temperature, but if we're picking 10 healthy adults, 98.95 would not be unusual because it's inside of this range. It's between 98.394 and 99.174. So we would say no there because it's inside of our average range. Let's look at another problem. All right, so a grocery store manager wanted to determine the wait times for customers in the express lines. He timed customers chosen at random. Here's a list of the wait times in minutes. So I am going to clear these two things out. I'm actually going to leave mean and standard deviation there because those are the first two things I need. And I'm going to change my list here to this data. So for this data, we have 3.3. We've got 1.2, 2.5, 1.8, 0.9, 2.4, 3.6, 5.2, 1.3, 1.6, 0.5, 2.0, 1.4, and 3.0. So hopefully I have typed everything in correctly there, and you can see here I've got 14 elements in my list, and you probably saw these numbers changing as I was typing that stuff in. So our mean and our standard deviation is already found here. The mean of the sample is 2.193 if I round that, and the standard deviation is 1.257 if I round that. So at a 95% confidence level, we need to know the approximate margin of error. So we're using that same formula over again, which is 2 times my standard deviation divided by my square root of my sample size. So for this problem, it's going to be 2 times that standard deviation, which is 1.2566. I'm going to keep that whole number and use it and copied and pasted in the calculator, divided by the square root of 14. So if I type that over here into Desmos, I've got 2 times this number right here, divided by the square root of 14, and I'm going to get 0.672. We'll just round that off there. So my margin of error is 0.672. So for the confidence interval, I'm going to take this and add it and subtract it from my mean. So my mean is right here. To get the lower number of my confidence interval, I am going to subtract my margin of error right here. And so that lower number, 1.521, is the lower amount of times that you would expect for someone to have to wait. Then, if I change it to a plus, I will get 2.865. Okay, so the next question asks us what this means in terms of wait times. Oh gosh, sorry about that. I was trying to type, but it doesn't want to let me do that. Here, I'm going to type it over here in Desmos because you won't be able to read what I write here. It's much harder to write on my laptop than it is my screen at school. So, for E, when it says, what is the meaning of the interval in terms of wait times for customers, it would tell us any sample of 14 customers should have an average wait time of between 1.5 to 1 and 2.865 minutes. All right, so that should be sort of your most likely wait times that you're going to see. If you increase the sample size, the margin of error would decrease. And the length of the confidence interval would also decrease. Okay, so again, the bigger the sample size, the more accurate it is. So your margin of error would be smaller. Your values would be closer to the actual value there. All right, moving on to a couple other types of questions you might see. These next problems don't give us the values that we have to type into Desmos to do the list. And these are, you're very likely to see these on the actual exam because they don't take as long to do, so they like to put them on there. So for number 6, a random sample of 60 students was asked how many minutes they spend on social media each day. The sample produced a mean of 92 minutes and a standard deviation of 22 minutes. Complete the sentence using the results of this study. This study shows that 95% of students spend between blank minutes and blank minutes on social media each day. So we need to know our margin of error, and then we'll look for our confidence interval for this. And then that should say 60, a sample of 60 students here. So we are going to take 2 times our standard deviation, which is 22, and divide that by the square root of our sample size, which is 60. So we're doing our margin of error is going to be 2 times 22 over the square root of 60, which is going to give us 5.680. So our confidence interval here is going to be, we're going to take our mean, which they tell us our mean is 92 minutes, and we're going to subtract our margin of error, and we got 86.320 is what that's going to be. So 86.320. And then for our positive, we'll have 97.680. Okay, so if you take any random sample of 60 students, you would expect their average to be somewhere between 86.32 and 96.66. 95% of the time it would fit in between those two numbers. 7 asks you to, tells you a company produces windshields. A random sample of 50 windshields was measured, and they found that the mean thickness of the windshields was 2.002 millimeters, with a standard deviation of 0.23. Choose all statements that are true. So this is not a multiple choice where you only choose one answer. You can have more than one true statement. The first thing asks us about margin of error, so we need to find that margin of error. So for this one, your margin of error, your standard deviation is 0.23, sorry. And your sample size here is 50. So you're going to have your standard deviation on top here and your square root of your sample size on the bottom. And I'm just getting 0.0065 right here, which is this first one. So that would be my margin of error. So that one is correct. But then you have another true statement here. It says the margin of error will increase if the sample size is increased to 200, or the margin of error will decrease if the sample size is increased to 200. So you can just check this pretty easily. What? Changing that to 200, and that is going to be 0.003 instead of 0.006. So our sample size, our margin of error decreased if our sample size increases. And even without numbers, you should know this is going to happen, because if you have a bigger sample, your margin of error should decrease every time. All right, so that sort of sums up what we have to know about margin of error. This part is a little bit trickier because it's a little more mathematical. You have to make some calculations. So I want you to go and do that second part of the practice quiz now, and you can retake it until you've made 100. And we will go over all of this tomorrow when hopefully, Lord willing, I'll be able to be back.